Good morning, good afternoon. Welcome to another webinar organized by Trimble, but this time together with Pointscene and Normi from Finland. We will give time to everyone to introduce themselves shortly. Today's webinar is about how mobile mapping data can facilitate automated traffic sign inventory, specifically here for the Finnish Digiroad. We'll go into details on the hardware being used, the software being used, and we will hear from Normi from a customer perspective about all this. All the attendees are automatically muted. If you have a question, please use the question box that you should see on your screen to type your questions, and we will address them at the end. Today we are with 4 presenters. And from 3 different companies. Myself, I'm Ronald van Koevoorden, the Advanced Solution Manager for Trimble, for the Europe, Middle East and Africa region, and as such also responsible for the sales of the mobile mapping solutions. And I'm joined today by Laurie and Jonny from Pointscene and Leo from Normi. And I will first give them a little bit of time to introduce themselves as well as the company. Laurie, I'll hand it over to you here.
Thank you very much, Ronald. Yes, so my name is Lauri Hartikainen. I'm the CEO and one of the co-founders in Pointscene, which I will tell a little bit further on the next slide. And together with me, we have Jonne Davidsson, who is our technical director and also a founder in the company. So Jonne, please.
Yes, hello. So thank you, Laura, for the introduction. Please continue.
Okay, good. So here we have some information about Pointscene as a company. The company was founded originally in 2014, so we are now a 6 years old company. We started out in Helsinki and now have a presence. We have a remote team in Sweden, Netherlands, and France. And we started out actually as a surveying mapping consultant company, but we evolved into a software as a service company quite fast after our establishment. And currently we are providing intelligent data solutions to connect, visualize, and analyze different types of geographical data for our customers within the built infrastructure segments. So our main customer base are within either civil construction works. We have some design engineering companies, and here today one of our asset management and actually asset manufacturing company with us. So this is our company in short. And please, next slide. So Pointscene, here we have the Pointscene sort of tree that we present our company with, because it describes our position and our offering quite well. So we are sort of a middle layer in between the data processing solutions and the end user solutions and end user applications within the construction and infrastructure segments. So our mission is to help our customers to digitalize their workflows and connect the digital information into different workflows and stakeholders. Today we are concentrating mostly on the 360 imagery part, but we also do have our platform solution provides tooling and web services for drone data or the photos, point clouds, surface models. We have a full cloud solution for the storage part, and then also the support for the laser scanning, mobile mapping, or terrestrial scanning or airborne datasets. I think there's a next button. So here today we're concentrating on the data analysis part, and this is Pointscene's sort of first solution around that topic more further. So in this webinar, we concentrate on the data analysis and especially for the 360 imagery part. Yes, thank you.
Hi, my name is Leo Mäkelä, and I'm work as a project manager, and my responsibilities are on the mobile mapping side of things. So I usually do all the technical stuff that is required to carry out mobile mapping missions and plan them and that sort of things. But in a larger scale, Normi as a company, here's the things we do. So we are involved with intelligent transport systems, street lighting, street signs, mining, and also traffic lights. The mining part is very minute. It's in heavily populated areas we do some mining, but other stuff is related to road and transportation systems. So basically, we do a little bit of designing of telematics and street lighting and traffic signs, and also install them on place and do some maintenance work also. But basically, everything that happens on the streets. Yeah, that's about it. Maybe we can go straight to the video.
Yep. We'll first show a short video in which kind of the whole case of today is very well explained. It's a little bit over a minute, so hopefully it comes through correctly for everyone. And I hope everyone can see the video.
I came from the mud, there's dirt on my hands. Strong like a tree, there's roots where I stand. Oh, I've been running from the law. Hope they won't shoot me down soon. They sing on a sleepless night. Try to catch me howling at the moon. 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 When it rains, it pours. Water's up to my chin. Won't stop fighting.
So yeah. As a Normi as a company, we are not trying to be a sort of mapping company or mobile mapping company, but we use it as a tool to make every of our tasks much easier. And there's a huge amount of data that we have to gather in order to, for example, these traffic signs. You have to gather immense amount of data and use it as a planning. How we're gonna replace all the traffic signs and stuff, and we get the idea that maybe we could do everything much better and end up buying this MX7 system. So with the MX7, we try to do whole thing, sort of inventory, so we know what we have and how much. For example, small towns and cities don't have any clue how many traffic signs they have, so they can sort of make any cost assessment or plans. And with this inventory, we give them a tool and exact cost assessment. And also, when we have very good data, we can use it in implementation and do the actual work and replace all the bad signs or do the maintenance work that needs to be done in 10 period of time in 10 years. So yeah, idea is to gather that data with the MX7 and use it in whole project. Yeah, that we could go to the AI solution. Yeah, next slide.
Okay, thanks, Leo. To start with, I'll explain a little bit about the Trimble MX7 hardware part. The Trimble MX7 is part of Trimble's mobile mapping systems portfolio, which consists of 3 different systems. We have a Trimble MX9, which is a high-end system that combines imagery and lasers, usually used on larger survey projects for all kinds of survey design, engineering, and large corridor projects. We have a Trimble MX2, usually being used for smaller projects, also having laser and cameras. But the Trimble MX7 is actually, what that we are talking about today, is actually quite a unique product, which is an image-only based solution, ideally used for asset management and documentation type purposes, for GIS inventory and maintenance applications. And like I said, it has it's based on a camera-only system. When we designed this system, we really wanted to look at creating a mobile mapping solution that was easy to use, easy to install. Up to the point of the launch of the MX7, mobile mapping systems could be quite complex with computer systems and all kind of things that you needed to install on or inside the vehicle. We wanted to make it easy to install, so that it also not only could be on a typical car, but also on different types of vehicles or kind of transportation tools. So it had to be easy to transport, easy to operate, so that you don't need lots of training to actually operate the system. And we also wanted to, with the system, make it more accessible for a wider group of potential users. So a cost reduction on compared to traditional mobile mapping systems was also one of the key design requirements. On the photos here, you see a range of photos from our beta users. So they got a system which is slightly different from what the system actually looks like now, but they helped us to define what the final product was going to look like. So what is the MX7 then? It's, as you see on the picture, a kind of tube that gets installed on the car. On the top, you have a spherical camera offering a full 360-degree horizontal view, or it gives you a 90% of a full dome image, including, it uses 6 different cameras, each 5 megapixel, which then generates a kind of 30 megapixel kind of total picture. Internally in there, we have storage of 2 terabytes, which is plenty of space to capture a long, big project. Now, to establish the position of the system, we first of all use, of course, GNSS, GPS GNSS technology. But besides that, there is an IMU in there as well, so that help keeping the position of the MX7 known. When you have GNSS outages, it also looks at the tilt and so on of the system, so that you have a correct position of your camera. Now, the principle behind this is that you don't just have pretty images, but that you actually can do measurement in the images as well to establish 3D positions of an object that you see in the images. And the very simple principle behind that is that you take photos every couple of meters. That's usually definable, but from that you then can see an object in one, two or more images, and by measuring that in these two or more images, you can then create a 3D point. As I said in the beginning, the system was actually meant to be very easy to use, and I think we have very well established that. You don't need any kind of complex computer systems in the car anymore. The MX7 by itself, with the control box that you have, provides a Wi-Fi hotspot to which you connect with the tablet, and on the tablet in the browser you start our Trimble mobile imaging software. That's the software that allows you to operate the unit. You get a nice background map where you can see what you have driven. You can actually load a plan into the background there, so that you can actually tell the driver where he has to go today, so that you can how to highlight the streets that you want to capture. So no long trainings or kind of long explanations needed to operate the system. It's very, very simple to use. And we see users of the Trimble MX7 in all kinds of different type of organizations, as well as applications. It could be from municipalities, road network owners, any kind of utility type of organization, forestry operations as well, people managing trees along major roads, and the list continues, and it's quite a variety of different uses there. And of course, once you have collected the data, then something has to be done with the data in an intelligent way, and that's where, in this case from today, the example is where Pointscene comes into play, and I'll hand it back over to Laurie.
Yes, thank you. So first of all, here's the sort of the process chain for the inventory. So it's quite simplified in this case, but it gives you an idea how the input data created from MX7 system and the post-processing tools that Trimble provides, how that input is converted into a geospatial dataset that you can access or direct into your systems, like Digiroad in this case. So the input data is, in this case, an oriented 360 imagery, and when we have the known feature types, like in our case, we have the Finnish traffic sign features, poles, and street lighting. So in case we have known already previously known types, we can just use the detection tooling with the trained neural network, and then when we have detected all the features that were supposed to be detected, we are triangulating those observations into geographical coordinates from the individual images. So we are basically first detecting those objects in individual images, and then triangulating the location based on multiple images, and therefore creating a very accurate geolocation for these detected assets. And in case we do not have, or in case there is a feature type that is needed to be detected that we don't have sort of weighted in our pipeline, then we can ingest or put in a additional task in between the input and detection pipeline. Ronald, please. And one more. All right. Yes. So if we have these sort of new feature types, let's say we would detect bus stops or some electrical boxes, we just simply do a manual visual annotation of the images. And then next, please. We have an annotated data set. For example, in Normi's case, we used about 10,000 images annotated, and we are reaching quite good accuracies and detection probabilities with that data set only. So it's a quite simple or quite fast task to add new feature types. And when we have annotated and done all the training part for the neural network, then we can direct these parameters into the detection framework. So one more. So when an additional type is added, or we go into a new geographical area with different types of visual signs, for example, then we can just add a new step or a middle step into the process and then apply it directly into the same pipeline. Next, please. So basically, this is an image of one individual frame which has detected all the different sign and pole and traffic light types. Next, please. And we are gathering that information into from all of the images, and then we are clustering those clustering those different observations into bundles so that we can define the geographical location for that asset. Next, please. Or maybe a few ones. So here's an example that, thank you. So on the bottom right, you see detections where we have one pole detected as a sort of brownish reddish color, and then we have two signs in each detected into the same pole. So it's quite nice and accurate presentation of how you can bundle these things so that you can actually sort of link the signs into poles, for example. So you have for the asset maintenance purpose, that is a good information as well, that how many signs do I have installed in one pole, etc. So we are detecting those sign types so that we have annotated, labeled, and trained now the Finnish versions of the traffic signs. So we have a labeled sort of data set for that purpose. And when you see, for example, the most common traffic sign in Finland is the back side of the traffic sign. So you get a quite good probability for the detection of that traffic sign. But we also detect the most common types quite in a good accurate way. Next, please. And beyond that, we also extract the detected features in the images so that it's easy for the end users, for example, take the data into Pointscene or into QGIS, like in this example, or any GIS solution where you can sort of use the detected features as a supporting material for the locations as well. Next, please. And here you can see what are the sort of the types that are the information attributes which are created in the process. So there's the class for the detected traffic sign type, for example, or object type. We have the map projection and the reference system for that, and the position in X, Y, Z coordinates. And then Next, please. Then there are sort of the observations still that we keep track currently. So we are calculating the intersections from the different observations, so that we are fitting these and triangulating these observations into accurate geolocations based on these overlapping observations. Next, please. So here are, for example, two observation sets where you see the individual images where this observation has been retrieved, and then fitted location for that particular location. And we are trying to cluster and filter out all the bad observations that might be coming in from a farther distance or some other erroneous detection. So we have quite trustworthy and reliable geolocation as well available. Next slide, please. I think. Yeah. So basically, as a summary. So the AI-based asset inventory that we provide, the required data for this process is georeferenced or oriented imagery. Currently, the best support is for 360 imagery, but planar images should be as good as another. And about LiDAR data, when it comes to, for example, MX9 system, that could be used for improving the geometric accuracy later on. The current object types that we map the road signs, at least the most common types, poles and street lighting. Yeah, and described earlier, the additional feature types or different sign types, for example, from different geospatial areas or countries, those can be added relatively quickly. And when it comes to accuracy, we are reaching sort of the similar level of accuracy comparable to the initial data. And as we have many observations and they weighted and triangulated locations, the relative accuracy reaches very, very high levels. And absolute as well. Of course, the better the data, the better the results. And the inventory speed is sort of 1-to-1 ratio with the captures. So we have a scalable architecture for the cluster, so that with 1 day of capture, a few days of processing is needed to provide this sort of standard output with the locations and types, etc. The Pointscene platform or the AI solution, it's cloud compatible, and we will provide also an API access for these tooling later on. Currently, these are run in a local installation, but it's a cloud compatible solution in any case. So providing this full solution from the cloud as a on-demand service will be possible in a near future, I would say. Next, please. So yeah, then Leo, please give your insights on this as well from the customer perspective.
Oh, yeah. So here you can see the quite a small town, and already you can get the idea how much data we have to gather. Only in this area there is 4,000 traffic signs, and going through all of them, it's quite a job, and AI is immense help in that process. Yeah, next slide, please. So about the must-have that we absolutely need in our tasks. First of all, when talking about traffic signs, we need to have quite accurate position. This is because we have to export all the data to the Digiroad, and for that purposes, it's very helpful to have a very clear position. And also a lot of our customers that we do the inventory demand at least 1 meter position accuracy. I would say half a meter is perfect for accuracy, and everything beyond that is a little bit overkill maybe. But we can achieve all this with the Pointscene AI solution very easily. Also, one good thing to have is a measurement of dimensions. For example, there is the top picture. There is a very large sign, and if you can calculate how big it is, how many square meters, we can actually calculate what kind of attachment system we must have. For example, if you have very high winds, we have to take that into consideration so that the structure can withstand heavy winds and rough conditions and that sort of things. And also the measurements help a lot in designing aspects. If we are going to, let's say, replace very signs in very high places or something like that, we need to have knowledge how what kind of crane we have to use in order to do the job. And also that everything related to actually construction work. Also the pictures, they must have quite high resolution, especially if the object that we are trying to look isn't next to the road. We have to have some zooming capabilities that we can read the text, what is written in it, and also the condition monitoring. It's very much easier if we have high enough resolution, which MX7 provides very nicely. Also, we have to have accurate bearing. This is especially important in Digiroad, where we put those, where we export the data, and we have to have knowledge in which direction the sign is actually facing, so we know what is its purpose and how it directs the traffic and that sort of things. On the other point is also the documentation part of things. We need to have, when we have, let's say, 2 kilometers long construction site that we are responsible for, we need to have clear photos of almost everything. We can't always know beforehand or what are the pictures that we need, and we used to take pictures with cell phones and try to gather every little detail that we might need. But with MX7 and 360 photos, it's so much simpler. We just gather everything and use the information that we need. It's also one of the trickiest part is the highways. First concern is, for example, safety. We can't just park the cars in middle of the road and jump out and take some pictures with cell phones or something like that. So it's so much safer to just drive with the MX7 straight through, and that's about it. Also, one key thing is that in many cases we need pictures from front and back side of things. For example, the bottom picture is if there is a very large sign, we have to know what kind of portal is used and what kind of attachment systems we have to use. And if the camera would be only facing front when we drive past it, we wouldn't get all the necessary information that we need in later part on the project when we actually swap the signs or do some other stuff. So 360 photos and accuracy are pretty much needed in all of our work. Next slide, please. So about the actual how we do things with the MX7, it's really straightforward and easy to implement. First of all, we make usually if there is a large area, we make a mission plan, and we basically upload the knowledge of the roads. In Finland, we have a database for every road, and we can just upload it. And on that left picture, you can see the red lines. Those are the roads that have been already mapped, and we just took the information and put it on the KLM format. And when we actually start driving and using the MX7, we can see on our tablet those red lines, and every time we actually start filming, we see blue line that is drawn on the map. So it's very easy to check, have we filmed everything, and what still needs to be filmed. It's very easy to gather all the necessary data, and nothing gets left out. So after the mission, we just need to make those 360 photos, which is quite easy job to do. I mean, fast, and give it to Pointscene that can gather all the relevant information about the traffic signs. So for example, if there's a small town, it takes 2 hours to plan the mission, 4 hours or 2 days maximum to film it, and 1 day to process the data and get the inventory. And it's very helpful because we get also the 360 photos that our customer can use in their purposes, whatever they are. And after we have all the information and data, we can send it to a Pointscene platform, and also the customer can look all the same pictures. They can look the data and give feedback or something. Also, it's very easy to use whatever geographical information system and just use the GeoJSON file and put everything on a map. And it's also very straightforward if you want to export the traffic sign data to the Digiroad, because we have to do very little work on that end when we have the inventory. Basically, just to use one large CSV file and upload it, and maybe do some quality check with the 360 photos. So everything can be refined afterwards. Next slide, please. So the benefits, we used to do this by walking on streets and using pencil and paper, and also cell phones and other sort of methods, but they were very clumsy, especially the documentation was really hard to do. And when we consider the Digiroad, we must have also the position data that this would make any sense. But yeah, the crunching through a massive amount of data, that's the one part that makes this worthwhile. and especially with the Pointscene's AI solution. Also, the easy communication with stakeholders. We can send the pictures to the customers, and we can also, when we have large construction sites, there's also usually some dispute. Did we break some things? And with those pictures, we can prove that we didn't break this kind of thing. It was already broken. Or there's so many use cases that we can use it. And one important thing is also that the documentation, it can always be improved because we have those 360 photos. So if we left out something or forget something, we can also always go back to the 360 photos and make the changes. Also, it's very useful. It's very scalable in a sense that we can, for AI, we can add more features like automated detection of road markings or guardrails or whatever. And also, when we have one mission that is well planned, we can always add information to our customers if needed. So basically, with the one carefully planned mission with MX7, we can make the inventory and refine it and make it always better and that sort of thing. And with precise inventory, the cost assessment is very easy. And with the inventory and cost assessment, the planning to do the actual maintenance job or whatever, it's very easy. And also, even the execution part is much more sufficient because we have all the information always that we need. We know what kind of attachment system we have to use, what kind of road it is where we are going, and what needs to be taken into consideration. So to finalize this, after using over 1 year of MX7 and Pointscene solutions, it's very hard to think how we would even go back in the prior methods, because this gives so much better documentation, information, and everything is just easily done, basically. But yeah, that's about it. Yeah, that's it.
Thanks, Leo. I think there were a couple of questions. Let me have a quick look. If anyone has other questions, then feel free to add that into the question box as well. One of the first questions was Laurie, I think you mentioned it earlier, it said 1 day capture is 1 to 2 days processing. How many kilometers can be captured in 1 day? And are there any capturing restrictions, like only specific hours or weather types?
Well, I think yeah, Leo might be a better answer. I might have a better answer here, but I would say that the roughly 200 kilometers, so 140 miles or something like that, would be a daily maximum. Or yeah, but Leo, please provide your insight. You have been driving a lot, or a lot more than.
Yeah, it depends on a lot of things. I would say in heavily populated area that we try to capture everything. Then it might be something like 100 kilometers, because there's a lot of streets that you can only drive to one direction, and then you have to come back and take this next street and so on and so forth. That takes some time. But if it's let's say main road from city to another. Then I actually, we haven't tested, but I think it might be even 1,000 kilometers per day. But you have to take in consideration also the driver, that drivers has to be swept in middle of the day. But yeah, there was also talk about the weather. In rain, the camera doesn't break in rain, but the images get very mushy because of the rain droplets. And we have filmed in midsummer to mid-winter, and it works fine in winter also. Of course, there might be a lot of scrap on the roads that gets into the camera, so you have to clean it a little bit more, but there isn't a lot of weather restrictions. Of course, if there's a lot of snow, you can't see actually the road or the road marking, so that sort of things, but you can still film it. Yeah.
Yep. Yeah, exactly. I think remember, this is a camera system, so any kind of restrictions you would normally have with a normal camera, you could apply here as well. So like you said, the raindrops coming on the lens it will impact the quality of the images. If it's perfectly dark, then obviously you don't get any content in your image either. So that are the typical things to think about as well. Another question was about the base maps and whether you could use Google Maps. Not completely sure to which part that refer to. In the data collection part, where of the mobile imaging software, there was a background map there that's using OpenStreetMap background, but you can load your own KML files in there as well. Instead of in the Pointscene environment, is there something where Google Maps API is being used?
Currently, no, but of course, I would think it would be possible if the question is related to uploading the results to Google Maps. That's definitely just a matter of converting the data into a proper format in order to do that.
Another question comes in, and that's related to, in some cases, in some countries, it's the use of the cloud is a challenge, especially also with some of this kind of data. So the question is about whether Pointscene could also be loaded in a server that the customer owns himself.
That's possible. We have cases where we are, for example, using our customer's Azure environment directly for data sensitive stuff. So yeah, it's a scalable platform in that sense.
Yep. There are a couple of questions related to pricing structures, license options. Not sure if you can say anything about that, but after this, I will show also the contact details. Then that can be also addressed afterwards, I guess. Let's see, there's some more questions here. There's a question about somebody that is familiar with our Trimble TMX software and whether this would replace the TMX software. This is a different approach than the Trimble MX software. Trimble MX software is providing a lot of tools for asset management as well, but the Pointscene solution takes use of artificial intelligence and does this in a very different way.
Yeah, and I would see that, for example, Normi, I think you have a compilation of these tools. So in the TMX or in the MX solution, there are a lot of tools and features that Pointscene will not provide when it comes to, for example, visualization or measurement. So we when it comes to inventories, we provide a certain sort of default pipeline with some extensions towards customer need and requirement, and then the visualization part and the browser-based usage part. I think we are not going to provide sort of a full toolkit that, for example, TMX can now provide and will provide also. So I think I would see that as a supportive toolkit for TMX, and then they're back. So
in Pointscene, are you able to manually measure some points? That, for instance, if you had some different kind of objects that you wanted to measure, that is not automatically recognized.
No, in the panoramic view, we don't have any measurement tools. But Jonne, maybe you can provide some additional insight on that.
Yes. So currently, we, as Lauri mentioned, we do not have the measurement capability for the panoramic images, but yeah, we have some ideas that are related to this in the pipeline. So, but the current status is that no measurements are possible.
Yeah, in Normi, we usually, if it's very specific job, then we take the MX7. But usually, when we done the inventory, the customer doesn't need and doesn't want to use the measurements. But if there's some more like engineering job related to designing and that sort of thing, then we take the TMX software, which is provided by Trimble, and but we usually there is no need for measurements in at least in our cases.
There's also a question that refers to something in the beginning about, say, stating that the data is free of charge. Not completely sure what that was referring to, but how is the investment done on capturing and processing and AI development earned back?
I think there might be a misunderstanding around that. So.
Yeah, I don't recall anything about saying about the data being free of charge, but of course data needs to be captured somehow, and there's some cost related to that, of course. But also another question about the recording of the session. Yes, it is recorded, and we will share. Everybody will get afterwards a link to the recording as well. Another good question is, especially in Europe, the GDPR regulations require that if you want to share data, for instance, that faces or license plates are somehow being made unrecognizable. And yeah, Lauri or Johnny, maybe you can talk a little bit about that as well. I think you have the tools for that.
Yes. So yeah, that wasn't mentioned in the presentation, but actually our AI journey started out with vehicle and the person detection and blurring. So we do have that available as well by request. So as for example, Normi's cases are mostly private sort of cases where there is no public usage of the data. So we haven't applied into all of those data sets. But yes, we do have a recognition and blurring or blackening, pixelating feature available also in the pipeline.
Mm-hmm.
Jonna, please, if you have add some addition.
Yeah, no, that's good. Yeah, no, just going back to that statement about the free data, that was actually coming from our introductory text to the webinar, that relates to Digiroad. Maybe it's good to explain a little bit what Digiroad is. Not sure, Leo or maybe.
Yeah, the Digiroad is basically digital representation about roads. There is restrictions where you can actually drive and with what vehicle and what are the speed limits and how much your transportation system can weigh, and all these things are taken into the roads. So basically navigation company can use that data and make the navigation better, because they can actually know how you can route people from point A to B and what are the restrictions on the way. And now there is also the new feature is the traffic signs and road markings and that sort of things. So it's I wouldn't say the digital twin might be wrong description, but it's basically digitized information about the roads.
Yeah, it's a sort of a GIS database of the center lines and the topology of the roads, and then the traffic signs and directions, surfaces, etc. So there are a lot of attributes that are tied into the geospatial data set or database, where each of the road segments has their both location and attribute information along with the asset data as traffic signs.
Okay, thanks. I guess one last question. I think you somehow addressed it already, but it's I guess about other types of things you might see in the image, for instance, center lines of roads or something like that. Long road markings, I guess, is the better way to say that.
Yes, yeah. So we try to take a very well scoped approach in detecting different types of features, so that we can actually get good results with a relatively small set of training data. So it can be, for example, for center lines or different types of paint markings as well. And for the neural network, it functions in a way that the data that is used for training is the detections that you get. So for example, one version could be that it detects just the paint markings.
Okay, thank you. I think that's are the main questions. Just to close off, I would just like to highlight one upcoming webinar that from Trimble side we are running next week. Those that are interested in wider use of mobile mapping, we're doing a session on the use of land mobile mapping systems for rail applications. On the website geospatial.trimble.com/webinars/home, you can see more details about this webinar, and you can register there as well. And finally, if there are any other questions, please feel free to reach out to us. You see here also the different contact email addresses from all of us, and yeah, I'll leave this here on the screen, but with that, we're closing the webinar for today. I thank everyone for attending this webinar, and also big thanks to Joni, Larry, and Leo for presenting today as well. Thank you, everyone.
Yeah, thank you.
Thank you very much.
Thank you.
Thank you, Ronald. And thank you, audience.